Most people think time is the one thing in the universe that never changes. But Einstein discovered something astonishing. Move fast enough, and time itself begins to slow down, and at light speed, it appears to stop entirely. Now, this isn't science fiction. It's a real prediction of nature, confirmed by experiments, and it forces us to question what time actually is. Stay with me, because by the end of this video, you'll understand why one of the simplest questions in physics led to one of the most profound discoveries ever made about reality. Most people think time is the most reliable thing in the universe. You wake up in the morning, you look at a clock, and it seems obvious that time just keeps flowing, second after second, minute after minute, day after day. It feels like the one thing that cannot be argued with. But nature has a strange habit. Whenever something seems completely obvious, it often turns out to be wrong. Today I want to show you one of the strangest discoveries ever made. A discovery so surprising that even after more than a century, people still struggle to believe it. The discovery is this: if you could somehow travel at the speed of light, time would stop. Now that sounds impossible. It sounds like the kind of statement somebody would invent for a science fiction movie. Yet it emerges directly from our best understanding of reality. The remarkable thing is that nobody started out trying to prove that time could stop. The story began with a much simpler question. What is light? Not what produces it. Not how bright it is. But what exactly is it doing as it travels through space? For a long time, scientists imagined that light behaved like waves moving through some invisible medium. Just as sound travels through air, they thought light must travel through something filling the universe. But every experiment designed to find that mysterious medium failed. No matter how carefully people measured, light always behaved in a very peculiar way. Its speed never seemed to change. Think about that for a moment. Imagine you're sitting on a train moving at 100 kilometers per hour. If you throw a ball forward at 20 kilometers per hour, someone standing on the ground sees the ball moving at 120 kilometers per hour. Velocities add together. That seems perfectly reasonable. Now suppose instead of throwing a ball, you shine a flashlight. Common sense says the speed of the light should also add to your speed, but it doesn't. No matter how fast you're moving, the light races away at exactly the same speed. This is not a small detail. This is a direct assault on common sense. If you're standing still, you measure the same speed of light. If you're running, you measure the same speed of light. If you're flying in an airplane, you measure the same speed of light. If you're riding a spacecraft through the galaxy, you still measure the same speed of light. Nature refuses to let the number change. And once you accept that fact, something extraordinary happens. Space and time can no longer remain what we thought they were. You see, the universe is like a giant accounting system. The books must always balance. If light speed is fixed for everyone, then something else has to adjust. And the thing that adjusts is time itself. Let's imagine a very simple clock. Not a fancy clock with gears and springs. Just two mirrors facing each other. A pulse of light bounces back and forth between them. Every bounce marks one tick. Simple enough. Now suppose that clock begins moving sideways. To someone riding with the clock, nothing changes. The light simply travels up and down, tick, tick, tick. But to an outside observer, the light follows a longer diagonal path. The clock is moving while the light travels. The light has farther to go. Yet the speed of light must remain constant. Nature allows only one solution. The light takes longer to complete each bounce. The clock runs slower. And here's the important point. Nothing is wrong with the clock. The mechanism isn't damaged. The batteries aren't weak. Time itself is running differently. This effect is called time dilation, and it isn't speculation. It isn't philosophy. It isn't an opinion. We've measured it. Atomic clocks carried on airplanes return slightly out of sync with clocks left on Earth. Satellites orbiting our planet experience different rates of time than people standing on the ground. If engineers ignored these effects, modern navigation systems would quickly become inaccurate. The universe performs this experiment every day. Now let's push the idea further. As an object moves faster and faster, the difference becomes larger. At everyday speeds, the effect is tiny. Drive a car, and you'll never notice it. Fly in an airplane, and it's still extremely small, but approach a significant fraction of light speed, and the effect becomes dramatic. Imagine a traveler leaving Earth in an incredibly fast spacecraft. Years pass for people on Earth. Cities change. Generations grow older. History continues. But for the traveler, much less time passes. Their clock ticks more slowly compared with ours. Their biological process is slow. Their aging slow. Everything inside their frame of reference continues normally, yet compared to the outside world, time stretches. This is where many people become uncomfortable. They ask, which clock is correct? The surprising answer is that both are correct. Reality is not built around a universal cosmic clock. There is no master stopwatch hanging somewhere in the universe. Each observer carries their own measure of time, and nature allows all of them. This idea feels strange because our brains evolved moving slowly. We never developed intuition for speeds approaching light. Our common sense was trained on bicycles, walking, and throwing rocks. The universe, however, is under no obligation to match our intuition. Now let's approach the truly astonishing part. As velocity increases, time slows more and more. Not a little more, a lot more. Then even more. The closer you get to light speed, the stronger the effect becomes. Mathematically, something remarkable occurs. The slowdown grows without limit. It's as if time is fighting harder and harder to move forward. Imagine watching a cosmic movie while continuously reducing the playback speed. First, everything slows slightly, then dramatically, then almost completely. The closer you approach light speed, closer time comes to freezing, and this leads to an astonishing conclusion. From the perspective of a particle of light, a photon, the journey across space takes no time at all. A photon leaving a distant star and arriving somewhere else does not experience the passage of years the way we do. To us, the light may travel for millions or billions of years. But the mathematics describing nature suggests that the photon experiences no elapsed time during its journey. Now stop and think about what that means. The sunlight touching your face this moment left the sun about 8 minutes ago. To you, 8 minutes passed. To the light itself, the journey is fundamentally different. The concepts of distance and duration become profoundly altered, and suddenly we find ourselves confronting a universe far stranger than anything common sense ever suggested. At this point, you might wonder whether time is some kind of illusion. Not exactly. Time is very real. Clocks work. People age. Events occur in sequence. Causes come before effects. The strange thing is not that time exists. The strange thing is that the rate at which time passes depends on motion. That idea sounds impossible, only because we're used to living in a tiny corner of reality, where speeds are slow compared with the speed of light. Suppose there were creatures whose entire lives took place aboard spacecraft, moving at tremendous velocities. To them, these effects would not seem strange at all. They would grow up knowing that time stretches and compresses depending on how objects move. What seems bizarre to us would seem ordinary to them. Nature itself doesn't care what feels intuitive. Nature only cares about what happens. And what happens is that space and time are woven together in a way that our everyday experiences rarely reveal. Think about a map. If you want to travel from one city to another, you can move north or south, east or west. Your motion can be divided among different directions. Something similar happens with space and time. The faster you move through space, the less you move through time. The slower you move through space, the faster you move through time. This isn't merely a poetic way of speaking. It emerges directly from the structure of reality. Right now, as you're sitting there listening, you're racing through time at the maximum possible rate available to you. Every second carries you forward 1 second. Nothing unusual seems to happen. But imagine gradually redirecting some of that motion into space. As your speed through space increases, your progress through time slows. The universe appears to maintain a kind of balance. And at the extreme limit where motion through space reaches the speed of light, motion through time drops to zero. Now that's a very strange sentence. Motion through time drops to zero. We use words like before, after, past, and future so casually that we rarely stop to examine what they mean. But near light speed, these familiar concepts begin to lose their ordinary meaning. Questions that once seemed simple become difficult. What does it mean for a journey to take no time? What does it mean for distance itself to shrink? What exactly is a moment? These aren't philosophical games. They're consequences of the equations that successfully describe reality. Let's imagine an extraordinary spaceship. Suppose engineers somehow build a craft capable of traveling at 99.9999% of light speed. The crew boards the vessel and departs for a star many light years away. From Earth's perspective, the journey may require decades. Families wait, children grow up. Entire technologies may be invented during the trip. Yet aboard the spacecraft, only a fraction of that time passes. Travelers return to find that Earth has aged far more than they have. This is not because they entered a magical portal. It is not because they suspended their biological processes. It happens because time itself unfolded differently along their path through space-time. The astonishing thing is that this scenario is not forbidden by physics. The laws of nature permit it. In fact, tiny versions of this phenomenon happen constantly. High-energy particles created in Earth's atmosphere provide a beautiful example. Some of these particles are unstable. Under normal circumstances, they should decay so quickly that they never reach the ground. Yet enormous numbers of them do. Why? Because they're moving incredibly fast. From our perspective, their internal clocks run more slowly. Their lifetimes stretch. As a result, they survive long enough to arrive at Earth's surface. Nature performs this experiment continuously above our heads. No belief is required. The particles themselves provide the evidence. And this reveals an important lesson about science. Many discoveries are difficult, not because they're complicated, but because they're different from intuition. People often assume that reality must conform to common sense. But common sense is merely the collection of experiences accumulated during ordinary life. The universe is much larger than ordinary life. When we investigate regions beyond everyday experience, reality behaves in ways that no hunter-gatherer intuition could have predicted. That's one reason these discoveries are so valuable. They remind us that understanding is earned through observation, not through assumptions. Now let's consider another strange consequence. Imagine chasing a beam of light. This thought experiment seems simple. You accelerate faster and faster, trying to catch up. You reach a tremendous speed. Still, the light races away at exactly the same speed. You accelerate even more. Nothing changes. The light remains just as fast relative to you as before. No matter how hard you try, you never gain on it. The universe refuses to allow it. And because the speed of light remains fixed, increasingly dramatic distortions occur in space and time instead. Distances contract, time dilates, energy rises enormously. Every attempt to reach light speed triggers stronger and stronger effects. It's almost as though nature has constructed an invisible barrier. Not a wall you can touch, not a force field, but a fundamental limit built into reality itself. The closer you approach that limit, the more energy is required. At first, the increase seems manageable. Then it becomes enormous, then absurd. Eventually, the required energy grows beyond all bounds. This is why objects with mass cannot simply accelerate to light speed. The universe won't permit it. Massive objects can get closer and closer, but never quite arrive. The finish line keeps receding. The distinction between matter and light suddenly becomes very important. Light has no rest mass. It doesn't begin as an object sitting still and then accelerate. It exists in a fundamentally different category. And because of that, light always travels at light speed. Not sometimes. Not usually. Always, the speed isn't merely something light happens to do. It's part of what light is. This fact leads us into one of the deepest ideas in modern physics. When we look around, we instinctively separate space and time. Space seems to be where things are. Time seems to be when things happen. But nature doesn't divide them so neatly. Instead, they form a unified structure. Events are located not only by position, but also by time. Change one observer's motion, and their measurements of space and time change together. Neither space nor time stands alone. They cooperate. They're pieces of a larger framework. And once you begin thinking this way, many apparent paradoxes disappear. The universe stops looking inconsistent and starts revealing an unexpected elegance. The same rules apply everywhere. The same principles govern stars, atoms, galaxies, particles, and observers moving at different speeds. What initially appears bizarre gradually becomes inevitable. You start realizing that time dilation is not an isolated trick. It is the natural consequence of a universe built around a fixed speed of light. The entire structure follows from that single astonishing fact. And perhaps the most remarkable aspect of all is that this discovery emerged not from enormous machines or distant space missions, but from asking a deceptively simple question. What would the world have to be like if the speed of light were truly the same for everyone? Once that question is taken seriously, reality begins revealing layers that had been hidden beneath ordinary experience for thousands of years. And every layer seems stranger than the one before. So, what have we really learned? Not merely that clocks slow down. Not merely that light travels at a special speed. We've learned something far more profound. Reality is under no obligation to match our intuition. The universe is stranger, deeper, and more beautiful than our everyday experience suggests. The flow of time that feels so absolute, so certain, is not a universal law written into the fabric of existence. It bends, it stretches. And at the ultimate limit of nature, it can even come to a standstill. That should humble us. Because every time we think we've reached the edge of understanding, nature quietly reveals that there is another layer beneath the one we thought was fundamental. And perhaps that is the greatest lesson of all. The purpose of science is not to make reality comfortable. The purpose of science is to discover reality as it truly is, even when the answer seems impossible at first. The fact that time can slow, that distance can shrink, and that light experiences the universe in a way completely different from us reminds us that we are living inside a cosmos far more extraordinary than imagination alone could invent. The next time you look at a clock, remember, time is not the rigid, universal thing it appears to be. It is part of a much larger and more mysterious structure, one that connects every star, every particle, every moment, and every observer in the universe. And the most astonishing part is that this mystery is not hidden in some distant galaxy. It is happening around you, every second, everywhere, all the time. The universe has been revealing its secrets from the beginning. The real question is whether we are curious enough to keep asking.